So now we're going to do problem 335. So this one deals with standard deviations. First of all, what's the difference between the carrier's highest data speed and the mean? Well, the highest was 78.1 and the mean's 15.91, so just subtract. So we can use a calculator, make sure we don't get any numbers wrong. So 78.1 subtract the 15.91. 62.9 or 19. So they want no rounding, so I used a 0.19. All right, second question, how many standard deviations? Well, a standard deviation is 39.57, so I just divide 36.29 by the standard deviation. We're just finding a z-score. So the spread is what we calculated in A. That's the spread from the x value, the highest value, to the mean. And now we want to know how many, that distance, how many standard deviations is that? And they want 2 decimal places. So 1.57. 1.57 standard deviations. The z-score, that is the z-score. They're just trying to trick us. The number of standard deviations from the mean is the z-score. That's exactly what the definition is. So they just want to make sure you know that. The carrier's highest data speed. Now, to be significantly high or low, you got to be more than 2 standard deviations from the mean. So we're about 1.5 or more or so. So we're not significantly high or significantly low. We would say it's not significant. We're in the middle. What we do is we're setting up a confidence interval of 2 standard deviations either way from the mean. Because it's easier to talk in z-scores of standard deviations than it is the raw scores, the x-scores. So since we're within 2 standard deviations, plus or minus 2, we're not significant. We have to be outside in the tails. That's always true in statistics. You have to be in the tails. If you're in the middle, you're usual. If you're in the tails, you're unusual, or significance, another word. So not significant. All right, so that is question 335. So I'm going to go ahead and stop this recording and get it processed.